So class, today we're moving on to our next lesson or our next unit. We're going to be talking about fractions. Now, since we did really well on the last unit test, I said I was going to bring in a pizza today. Well, I did. Here's our pizza. But I'm a little confused on how you would eat a pizza. I haven't seen them all too often anymore. And I was wondering if you knew how you would eat a pizza. Like, would you just leave it as a whole, or do you have to cut it up any, or do you have to pick it up, or just eat it with a fork? That kind of stuff. Then after some time, I would continue and say that, well, you wouldn't really just pick up a whole pizza. You would cut it up into smaller pieces, right? Well, those are called slices. And some ways that you can see pizzas cut are in half, in quarters, but it's rotated a little bit, and eighths. Now, our pizza looked like this one, except this one is perfectly cut into where each of these little sections are all the same size. But what is a slice, really? So we're going to take a deeper look at that here. So we have our whole pizza, and we cut it up into these little pieces. It's all the same size still between this whole and this one. This one's just broken down and cut up more. But now we're going to look at seeing just what is a slice. We say a slice is something, but, what actually is it? And then after some more class discussion. Right, it's a fraction. This section right here is part of this bigger pizza. Because this pizza and this pizza, it's the same size. This one's just cut up. So if you look at one of these slices, it's a fraction. And so a fraction then must mean that it's a smaller part of a bigger whole. Because all these little slices add up to the one big pizza. So let's look at a party here. And say that, we're bringing the pizza, we eat the pizza. And there's only one little section here. This section right here. That my cursor's on and the arrow's pointing to. Does anyone know how you would write that? So we're looking at one of the 8 parts of pizza. And if I was in a classroom setting right now, I'd be able to write, 1 and then over 8 and everything. But currently I don't know how to do that with this. But we're looking at 1/8 of a pizza. And that 1/8 that's the fraction. That's just a different representation of this little slice here. Now, if you ate a whole pizza, there's nothing left. So we had to have something left there. But you can continue with that then. Say there's 3 slices left. Then you have 3/8 is your fraction of a pizza. Because all of these are the same size, so each of these little sections holds the same value. So this one is 1/8, this one is 1/8. They're all 1/8, which is why you can put the 3 of them together and get 3/8, because they need to be the same size. So that way they have the same value. Now, fractions do apply to more things than just pizza. Pizza is just, who doesn't like pizza? Different ways it can be is, here's something similar to our pizza example, but it can also be shaded shapes. So here would be half of a triangle is shaded, the other half isn't shaded. Here's a series of squares inside a rectangle, so that would also be half as well. All of these are half except for this one and this one. But see, there's different ways of looking at fractions visually, at least. But here are some of them. You might see shaded squares, shaded rectangles, different circles, but there sometimes might be a break in them, different triangles in a set. But all of these still apply. So this would still be half. This is still half, even though it looks differently. As I said previously, the big point is that this piece and this piece are the same size. Another way that could be looking at it is shaded circles. Where here you have 1, 2, 3, 4 shaded circles, and 1, 2, 3, 4, 5, 6 not shaded circles. So there's 10 of them in total here, but 4 are shaded. So that would mean it would be 4 out of the 10, or 4/10 are shaded would be your fraction here, which can reduce down into 1/5, but we'll expand on that in another lesson moving on. The first center we're going to be doing is something similar to what I just showed you, called what fraction am I? There'll be shaded dots, squares, all the different makeups that we've seen so far, and that it's your goal to then determine the size of the fraction. So walking through a couple of them here with you, this one would be 1/3, since how all these pieces are the same size, but only one of them is shaded, and you're trying to find the fraction of the shaded portion. Not the not colored in portion, just the shaded. Another one here would be, this would be 1/2, or something similar. This one might be a little small to see in the back, but this one is also about 1/2. Or this one is 1/2, about. Center 2 is fraction creation, where you're going to be given some of those different representations, or different drawings or visuals of the shapes. And now, it's up to you then to create your own fraction. So you'll actually be coloring them in, and then it's up to you to then figure out. So say if you colored in, all of these boxes, that would just be 1. So ideally you don't want to do that one. But here you would look at, say you filled in, this was what you would fill in. Then you would have 1, 2, 3, 4, 5, 6, 7, 8 out of the 12 shaded in. So you'd just be doing something similar like that. But there's different colors back there, different shapes and all that stuff for you. The last center you're going to be doing is what you have to be really careful with, called which is bigger. So this center, you're going to be looking at 2 different fractions. They can be squares, they can be circles, they can be anything that you've seen up until this point. It might be dots. And you have to compare them to see, well, which is more, essentially, or which is bigger. Because it's not always going to be just a circle to circles, or boxes to boxes. Sometimes you might have to look at boxes to a circle, but 3/4 is still 3/4, and that's always going to be bigger than, say, 1/2, at least from looking at which fraction itself is bigger. The object might not be bigger, but the fraction itself will be bigger. So for here, you would see that 3/4, so 1, 2, 3 of the 4 are red, and that's bigger than 1, 2, 3, so then bigger than 2/3. So 2/3 here is smaller than 3/4. For right now, we're mainly going to be sticking with just circle to circle, or blocks to blocks, and that kind of stuff. Similar here, something you might see is going to be looking at the blocks, as I mentioned previously, where you have 1, 2 shaded in, but 3, 4, 5, 6, or 4 not shaded, so you have 2 out of the 6 shaded. But this type of one, you're actually looking at which piece is bigger. So for the circles, you're looking at which fraction is bigger. Here, you're looking at which piece is bigger, or which has more, essentially. That's correction on that one. You're not looking at the fraction in this one. You need to determine that the fraction is, at least for these ones. So this one would be 1, 2, 3, 4, 5, 6, 7, 8. That one would be 2/8 are circled, where this one is 1, 2, 3, 4, 5, 6, 2/6. So 2/6 is bigger than 2/8 on the same one. So you are still looking at the fraction, but you're also able to look at the pieces and see, well, that's why 2/6 is bigger than 2/8, because it is just physically bigger. You have bigger pieces rather than smaller pieces. And that would be the end of the lesson. Sorry for the confusion at the end. Thank you, Dr. Malat, for being able to listen to this, and I'm sorry I was had drill here over the weekend, so it might seem a little, I don't want to say thrown together, but it's not. I had this presentation up and everything, just trying to get everything done. That way you can get it in and graded, so I'm not holding you up either. Thank you for your time, Professor, and hopefully I'll have you for another course down the line. I've already had 2 with you, and I've enjoyed both of them very much. Goodbye.